Oxidation states have a couple rules. For one, oxidation states of elements are always zero. Oxidation states for representatives is their ionic charge most of the time. 3. Oxygen is always -2 unless it's peroxide. 4. Hydrogen with nonmetals is given +1 oxidation state. Unless it's with a metal, then it's -1. And number 5, the sum of oxidation numbers must be 0 for compounds and whatever the charge of the ionic species is. There are several steps in balancing redox reactions. First, we have to assign oxidation numbers to the species in the reaction, then find substance oxidized and substance reduced. Third, we have to write half reactions for the oxidation reduction and balance the atoms that change in the half reactions in each. We determine the electrons transferred and balance the electrons between the half reactions. We combine the half reactions and balance the remaining atoms. After that, we check the work and see if we did it correctly. Here's an example.
The example we're using is the reaction of the dichromate and sulfur dioxide molecules to form chromate 3 ion and the sulfate ion. By looking at oxidation states, we can determine that chromium will be reduced while sulfur will be oxidized. We start by balancing chromium, then add 7 waters to balance the oxygen. We then add 14 hydrogen ions to balance hydrogen. Finally, to balance the charge on both sides of the reaction, we add 6 electrons. Sulfur does not need to be balanced, so we add 2 waters to balance oxygen, 4 hydrogen ions to balance hydrogen, and then 2 electrons to balance the charge. The second half reaction must be multiplied by 3 so that the electrons transferred are equivalent. Finally, the 2 half reactions are added together to reach a final reaction. The reaction is simplified by crossing out common molecules. If you're balancing in a basic solution, you add hydroxide ions to both sides of the reaction until no hydrogen ions are present anymore.